my name is Giuseppe Caccia and I will introduce you the runtime manager for SPACE4AI-R. After the iSprint application has been designed, deployed, and is up and running, the scope of iSprint tools is not completed. We need to guarantee that the application keeps running and keeps running in an optimal way. The iSprint runtime architecture allows a real-time adaptation of the application deployment based on the running condition. The iSprint runtime adaptation is obtained by the cooperation of two different set of tools. The iSprint modular subsystem, that is a tools that collect all the information about the running condition as the network status, the application load, and so on, and the SPACE4AI-R that consists of two tools, the optimizer in cooperation with the AM library and the runtime manager that is a sort of orchestrator of all these kind of tools. Once we collect all the running conditions, the optimizer finds the optimal deployment and the runtime manager deploy the optimal application in a seamless way, avoiding any kind of data loss. This picture shows how all the iSprint tools cooperate to get the application running in an optimal way. Let me to focus your attention on the cooperation between the runtime manager and the modular subsystem. The runtime manager collects data from the modular subsystem in a periodic way, collecting all the data on the runtime status, but the modular subsystem can also push notification to the runtime manager on particular network condition, load condition, when there's detected some kind of error. Then the runtime manager passes this information to the optimizer, and that based on the current deployment found the optimal deployment based on the detected runtime condition. Then the runtime manager uses the Scannerizer and all the deployment tools, the infrastructure manager, Oscar, SCAR, and Minio, in order to redeploy the optimal application. There are many kinds of iSprint application deployments, but all comes into specific categories. The one in each where all the components of the iSprint application are in the cloud, and the one where some component of the iSprint application are on the cloud and others are in the edge. In case we have an iSprint application with the component that they are split between the edge and the cloud, the runtime manager comes in two different flavors: the edge runtime manager and the cloud runtime manager. This sort of runtime manager twins work together monitoring the network connectivity. If the network connectivity is okay, only the runtime manager on the cloud is in charge to make all the optimization for the iSprint application. Instead, when the runtime manager detects a loss of connectivity between the cloud and the edge, both the runtime managers start to optimize the components, one on the cloud and one on the edge. The runtime manager on the edge switch off all the computational nodes but two in order to save cost. Instead, the runtime manager on the edge started to optimize the edge component, for example, using components with degraded accuracy. As soon as the connectivity has been reestablished, the runtime manager on the cloud start to enable the sending of the data to the cloud. The cloud parse and process the burst of data coming from the cloud, and then once the data burst has been processed, the runtime manager started to optimize the configuration again. Once deployed, the iSprint application running condition can vary due to loss of network connectivity, due to network congestion, network load, network delay, and based on the load of the component of the application. For this reason, it is needed a system in order to monitoring the runtime condition and to reapply to find an optimal deployment in terms of topology and flavor and deploy this application in a seamless way without any kind of data lost. And the iSprint tools allows a forecasting of the optimal deployment based on the detected running condition. Without iSprint runtime tools, the developers need to design and deploy a runtime adaptation mechanism for the application. Instead, with iSprint, the runtime adaptation mechanism and the tools are entangled with the iSprint application itself, allow the developer to focus on the application itself and not on the adaptation on the runtime. Let's see the iSprint runtime in action. We will have an application deployed on the cloud, and we will adapt the configuration of the application based on the changing network condition.